Hey everybody, Mr. Conan here today, and I'm going to talk to you about how to solve a quadratic equation by graphing. Now, this is going to look similar to another video I've done before, but at the end I'm going to add a little bit of little piece that is going to explain exactly how to solve a quadratic by graphing. So, let's go through the process as normal. Here I have y equals x squared plus 4x plus 3. Now the first thing I'm going to do is identify my a value, my b value, and my c value. Again, we get these values by looking at the term in front of my x squared for a, the term in front of my x for b, and the term without an x for c. My next step is going to find my axis of symmetry. Now the axis of symmetry can be found by plugging into the equation x equals negative b over 2 times a. When I plug in my values for this equation, I have x equals negative 4 over 2 times 1, which gives me negative 4 over 2. Give me x equals negative 2 as my axis of symmetry. Now I can write this out on my graph. I'm going to go to x equals negative 2 on my graph, and I'm going to draw a vertical line up and down. I'm going to write that x equals negative 2 up top just to remind me that that's where my axis of symmetry is. Now that I've found my axis of symmetry, what I can do to find my vertex is plug that into the original equation. So when I plug in negative 2 to my original equation, I have y equals negative 2 squared plus 4 times negative 2 plus 3. When I simplify this all out, negative 2 times negative 2 is 4. Negative 2 times 4 is negative 8. And then we just have that plus 3 on the end. So when I add 4 with a negative 8 and a positive 3, I'm going to get negative 1. So I know my vertex is located at negative 2, negative 1. I can actually plot that point on my graph by going to the left 2 and then down 1. Now that I have my vertex, I can start finding the other values that are on my parabola. So I'm going to plug negative 2, negative 1 into my xy chart. Now I'm going to count backwards to see the two numbers to the left of my vertex, negative 3 and negative 4. And I'm going to count forward to get the right two values, the two values to the right of my vertex, negative 1 and 0. Now I can choose which two values I want to plug into my equation to get the rest of the values. Because it's going to be easier for me, I'm going to deal with negative 1 and 0. So when I plug in negative 1 to my original equation, I have y equals negative 1 squared plus 4 times negative 1 plus 3, which simplifies to negative 1 times negative 1, which is 1, minus 4 plus 3, giving me my y of 0. Now when I plug in 0 to the original equation, I have 0 squared plus 4 times 0 plus 3, 0 plus 0 plus 3, which gives me an answer of y equals 3. So now I'm going to plug that also into my table. Now as we can notice, because my axis of symmetry is at x equals negative 2, I know that my y values for negative 3 and negative 4 are going to be reflections of negative 1 and 0. So my y value for negative 3 is going to be 0, and my y value for negative 4 is going to be 3. So now we can actually plot these points on my graph. When I go over to the left 4, I go up 3. When I go over to the left 3, I'm going up 0. When I go to the left 1, I'm going up 0. And when I'm just at 0, I'm going up 3. So now we can actually draw my parabola in. Now we're getting to the fun part. Let's talk about the solutions of my equation. So the solutions are going to be the x-intercepts of my graph. This is where my y equals 0. So when we were talking about solving a quadratic by factoring, we had to set our factored form of quadratic equal to 0. So our solutions to this equation are going to be right here and right here. Or when my y is 0, so x equals negative 3 and x equals negative 1. Our solutions are x-intercepts. You may also hear them be called zeros, and you might also hear them be called roots. They are all the same thing. Those are the solution for our quadratic equation. If you have any questions, feel free to email me at nconine, that's N-C-O-N-I-N-E, @smcm.edu. Thank you and have a great day.